Hello everyone, in this video we will talk about similar polygons. The first part of the lesson is about identifying similar polygons, and the second part is using properties of similar polygons. Here we have an example. It says if triangle ABC and XYZ are similar, that symbol means similar. List all pairs of congruent angles and write a proportion that relates the corresponding side. Let's get started with the angles then. So these angles are going to be corresponding. We are going to determine those angles by using the similarity statement. So if you look at the similarity statements, the same spots, the angles in the same spots are going to be congruent. For example, A and X, angle B and angle Y are congruent, angle C and angle Z are congruent. So let's make a list of these angles. Angle A is congruent to angle X, sorry about that, angle X. Angle B is congruent to angle Y, and angle C is congruent to angle Z. So now we are done with the congruent angles. We are going to write a proportion that relates the corresponding sides. I'm going to make a list of all possible proportions. Their measures are going to be the same anyway. For that, we are going to use this similarity statement again. Remember, to name a side, we need 2 points. For example, side BC, we need 2 points to name a side. So we are going to look at the statement, left hand side of it, choose any 2 of them, like A and B, and then find their corresponding points, X and Y. So we are going to take AB and divide it by XY. This means if AB is 3 units, we are going to write that number in the numerator. If XY is 5 units, we are going to write that in the denominator and then divide them. That's going to be our proportion. This can be one of the proportions. Also make another side BC, for example, side BC over YZ correspond to BC, and also AC and XZ. So I want to go over this again. B and C are the second and third letters, and Y and Z are second and third letters. They correspond to each other. AC, the first and third letters. XZ are the first and the third letters. So we are done with this question. This is how we write the congruent angles by looking at the similarity statement. And this side right here is how we write a proportion by looking at the similarity statement. So let's move on to the next example. It says determine whether the pair of figures is similar. So we have one pair of figures here. They have 4 sides, they're quadrilaterals. If they are similar, write the similarity statement and scale factor. Explain your reasoning. So let's get started by comparing the angles. We need to start with the angles. If we quickly look at the angles, W has one of these symbols, P has the same thing. So that means the angle measures are the same. So let's just write what we just said. Angle W is congruent to angle P. Now let's move on to angle Z. Angle Z has 2 of those symbols right here. Same symbol is on angle S. So these 2 angles are congruent as well. The next angle on the figure on the left is angle Y. It has 3 of those symbols, and angle R has the same thing. The last one is angle X. It has 4 of them, and same symbol is on angle Q. That's why they are congruent as well. Now let's compare the sides. So if you look at the sides, WZ and PS, the ratio between these 2 sides is 9/6, right? 9/6. And if we simplify these 2, divide each number by 3, we get 3/2. This is the ratio between WZ and PS. So let's write it up here. WZ over PS is equal to 3/2. Now let's move on to the next pair of sides, like ZY and SR. So ZY over SR is equal to 15 over 10. Divide each number by 5, we get 3 over 2. The ratio is the same. So we need to compare the other two pairs. XY divided by QR is equal to 18 over 12. Now, again, we are comparing these two sides. 18 over 12. Divide each number by 6, we get 3 over 2. The last pair for us to compare is WX and PQ. Their measures are 12 and 8. Divide each number by 4, we get 3 over 2. So since each pair of sides have the same ratio, 3 over 2, we say the the quadrilaterals are similar, and these are the similarity statement ratios and corresponding angles. And the scale factor is, we can say scale factor is equal to 3 over 2, and the similarity statement is gonna be written from these statements. So start from any of these points. All of these, the left hand side, these belong to the first figure. So make a list of those points. W, Z, Y, X is similar to, now we need their corresponding pairs. W corresponds to P. Do the same thing for the other points. P, S, R, Q. That's all for this question. So let's move on to the next example. Here we have two examples. The first one is about the previous concept. We are going to determine if the triangles are similar. If they are similar, we are going to write the similarity statement and scale factor by explaining our reasoning. So remember, if you're looking whether the triangles are similar or not, we need to compare the angles. We need to show that the angles of the triangles are the same. By the way, the triangles are, the first one is here, PQR. Angle P has one symbol on it, R has two of them, Q has three of them. And then the second triangle is this one right here. Look at the angles of this purple triangle. Angle P has one of those symbols, T has two of them, S has three of them. So they are the same. The angles are the same. So let's write the similarity congruency statements for the angles. Angle P is congruent to itself. It belongs to both of the triangles. The next one, angle R, is congruent to angle T because they have the same symbols, two of the angle symbols. The next pair is angle Q from the small triangle is congruent to angle S from the big triangle. Now, just by looking at these three statements, we can make a list of the sides, like PR divided by P and R belongs to the small triangle. Their corresponding pairs are PT. Okay, the next one here is RQ and TS. The last one is PQ and PS. So let's see if we know any of these measures. So if I look at the figure, I realize that I know QR is 11, ST is 22. I'm going to write them on the segments. QR is 11, TS is 22. If I divide 11 by 22, I get 1 over 2. Simplified. So this is our scale factor. And remember, if you have a small triangle, like this one, inside of a big triangle, they are 100% similar all the time. If you have any pairs of sides that correspond to each other with their measures, just divide those numbers. That's going to be your similarity statement. That's going to be your scale factor. So for sure, PR over PT is going to be 1 over 2, and then these two sides, the ratio of these two is going to be 1 over 2 as well. So this is going to be 1 over 2. This is going to be 1 over 2. Here's a quick proof of this. So if we assume this is A, as you see, QS is A as well, because they have the same symbols. So we have A plus A for the side PS. We have two of these a's, so the whole side becomes 2a. Same thing applies for PR. Let's say this is B, this is going to be B2, and the whole side is going to become 2B. Now let's look at the ratio. PR, let's look at the PR, it is B, and PT is the whole thing. B over 2B gives me B over 2B is equal to 1 over 2. And same thing applies for this ratio. PQ is A, PS is 2A. A divided by 2A is 1 over 2. This one is 1 over 2 as well. So as you see, the sides have the same scale factor, which is 1 over 2. We can write the similarity statement. Let's write the similarity statement for these two triangles using the congruent angles. So I'm going to go by order. PRQ is congruent, similar to PTS. That's what I'm going to write. Triangle PRQ is congruent, sorry about that, not congruent, is similar to triangle PTS. So that's all for this question. Now we have our similarity statement for the triangle. We have our reasoning. The reasoning is angles are congruent, sides are proportional. That part is right here. And 1 over 2 is our scale factor. So let me put it up here. Scale factor is equal to 1 over 2. So let's move on to the next example. Use properties. This part is about using properties of similar polygons. We have two triangles. It says the two polygons are similar. So we know the angles are congruent. The sides are proportional. It says find x and y. So if the sides are proportional, then we have the corresponding sides. The ratio of them is going to be the same. Like 32 and 16. They correspond to each other because look at the endpoints. It has one of these angle symbols and it has three of them. We have the same symbols on the endpoints of this side. So if we divide 32 by 16, we get, divide each number by 16. We get 2 over 1. This is our scale factor. This is the ratio of these two triangles. It's in every single pair of the segments that correspond to each other between these two triangles. So now let's look at this side. It has x in it. So x over its corresponding side must be 2 over 1. The corresponding side of x is 13. So now we are going to write a proportion using the similarity statement, using the scale factor. Sorry about that. So the scale factor is this one right here, 2 over 1. So now what I have is x over 13 equals 2 over 1. We are going to do cross multiply. X times 1 is x. 2 times 13 is 26. This is what x is equal to. Now let's do the same thing for the other pair of corresponding sides. 38 and y correspond to each other. So 38 divided by y must be equal to the scale factor. We figured it out. It was 2 over 1. Now do the cross multiply. Y times 2 is 2y. It equals 38 times 1 is 38. We need the value of y. We divide each side by 2. So y would be equal to 19. And we are done with this question as well. So let's go over what we did in this example. First step, figure out the scale factor. Find the sides that have their measures and they correspond to each other. So these two, scale factor is 32 divided by 16 equals 2 over 1. Take that scale factor, set it up to equal to another pair of corresponding sides, like x over 13. And do the same thing for the other pair of sides. Do cross multiply, solve it for the variable. Here's the last example. This one is again about using properties of similar polygons. We have similar triangles. It says if triangle DEF is similar to triangle GHJ. Find the scale factor of triangle DEF to triangle GHJ and the perimeter of each triangle. First, let's start with the scale factor. scale factor of triangle DEF comes first. So what we need to do is we need to find a pair of corresponding sides. 10 corresponds to 8j. I know this because if I look at the statement here, similarity statement, the endpoints of 10 are E and D. They are the first and the second letters, and their corresponding points are G and H. But I don't know its measure, so I just skip that one. 12 corresponds to GH because the angles in the endpoints of the side is 1 symbol and 3 symbol. 1 and 3, so these two correspond to each other, but I don't know the measure of GH, so it's kind of useless. But EF and HJ, their measures are given. So I can use those numbers. Scale factor is equal to 8 over 12. Divide each number by 4. 8 over 4 is 2. 12 over 4 is 3. So now this is the scale factor. So this scale factor is going to be equal to the ratio of the perimeter of the triangles, right? So how do you find the perimeter of this small triangle? Add the sides all together. 10 plus 8 is 18, plus 12 is 30. So now, and the perimeter of this one, let's say, is x. We don't know what that is. So the scale factor between the triangles are 2 over 3. It must be equal to the ratio of the perimeters. So the perimeter of the small triangle is 30 divided by the second triangle's perimeter. To cross multiply, 2 times x is 2x equals 3 times 30 is 90. Divide each side by 2. 8 equals 45. 8 was for the perimeter of the big triangle, triangle GHJ. It is equal to 45. That's all for this lesson, guys. If you have any question, please comment below, and I will see you in another video. Thanks for watching.